On to the exercises, which we will read in 20 years of Microsoft data. So just Microsoft, different data from Microsoft. In which week did Microsoft have the greatest number of its shares traded? So the volume. Okay, so we do have the date time in the index, so we can use resample and we can group by week. We can get volume and take the sum of this. And then we could just take the IDX max and the max of this. So we can see here that the greatest number of shares traded were on this week. So W, the last day, this is a Sunday, but it's just for that week. So the Monday to Sunday before this. And here is the total volume for that week. All right, number 2, with help from the diff method, find the quarter containing the most number of up days. An up day is when the adjusted close of the current day is greater than the previous day. Okay, so let's get the adjusted close over here, and we'll do dot diff. And if it's a positive number, that means it increased, right? So the very first adjusted close, it went up. So we're going to test this whether it's greater than 0, and I'm going to save this to S. And all we want to do is figure out what is the most number of up days in a quarter. So S dot resample quarter and take the sum of this. So this is the number of up days in a quarter. So quarter is 3 months, is approximately 22 days per month of trading days, about 66 trading days. So you can see here, the most you can get is probably around 66. So let's, again, we figure out the most of this. And then we'll do the same thing. So max and IDX max of this. So we can see the most is 43, and it happened in December of 2001. So that last quarter of 2001. Number 3, find the mean price per year along with the minimum and maximum volume. Mean price per year along with the minimum and maximum volume. Okay, so here's Microsoft data. Price, I mean to say adjusted close. And we will resample this by year, mean price per year, along with the maximum and minimum volume. So actually, not just the adjusted close. So we're going to say ag, and I'll say mean price equals adjusted close, comma means. We'll take the mean of that, and then we'll say min volume min, and max volume max. All right, so that's per year, and so that looks good. All right, we can actually round this to just 1 decimal place to get a little bit cleaner. All right, great. Number 4, find the mean of each column for every 6-month period. Okay, so for every column, so we'll resample 6m dot mean. The first time period should start on the month in the first row. Okay. So the way Pandas works, again, this is confusing. This is really the last month of the 6-month period. So there's not a whole lot of activity here. This is just the last few days. This is the full 6 months from November 1st to April 30th and so forth. All right. Now number 5 says repeat exercise 4 using a time span of 3 years. So where the year begins on July 1st. So let's just do AS July. So this is the beginning, the start. So this makes a little bit more sense. So this is the start of the period. So July 1st all the way to June 30th of 2001. So it's that 3-year period. All right. Repeat exercise 5 using the group by method instead of resample. So we can do this. Just go here. We'll say group by, and then we just want pd.grouper. And we want the frequency parameter to be that. So it's pretty simple to substitute in, and you should get the exact same result. All right, use the temperature data set here. Find the mean temperature for every city for every 8-hour time period. So notice over here we have hours this time. So temp.resample 8h.mean. This will do for every column. So there we go, every 8-hour time period. Verify that there are 24 rows for each day. So how do we know there's actually 24 rows in each day? We do temp.resample. We can resample by day and then do dot size like this. And this is all, they should all be 24. And we can do a number of things. We can do dot value counts, and this should be the only number that appears there, or really probably better just to do unique. So this is the only unique number. All right, exercise 9. For each month, return maximum temperature amongst all cities. So temp.resample m. So this is the temperature dot max. So there we go. All right. Number 10, for each month, return the maximum temperature amongst all cities with the city name where the maximum occurred. Return a 2-column data frame where the first column is the maximum temperature and the second is the city. The index should be the month. Okay, so there's a lot of words here. So let's go ahead and call this again. Amongst all cities. Okay, so all I want to do is aggregate over here. I want the max and IDX max over here. So we can do by column. So let's just look at the whole data frame again. It's going to find the maximum of every column. And what we're trying to do, actually, we need to do access equals 1. We need to do it the other direction. So return a 2-column data frame where the first column is the maximum temperature. There we go. And the second is the city. So again, let me comment this out. So let's go back over here. So I need to go by row. So of this row, which city has the highest temperature? Well, it looks like, so Miami has the highest temperature in January of 2013. So I want to find the max of this row and then also the index of the max, which is just the column name. So that's why I do max and IDX max. And by default, it goes up and down, but I need to do it horizontally here. That's why I change access equal to 1. All right, so this is pretty cool. You can see here, Las Vegas is warmest in the summer. So this is just a single day maximum. So we actually have Denver having a maximum over here. This looks like quite an outlier over there. But anyways, so it's a pretty cool problem on aggregating and then aggregating again on that on the aggregated data. All right, so that is it for the exercises.